All right, guys. They said that what list the reactions of urea cycle and add a note on the significance of this pathway to man. All right. So this one, they are just trying to drag you to talk about everything that has to do with what the urea cycle. So before you can be able to talk about this question or answer this question, you must actually know how to draw the urea cycle. Of course, you can't define all of this without drawing the urea cycle. So once you draw the urea cycle, you have answered the question 70%. Of course, importance to man, urea cycle is important in what excretion. Okay. So looking at this now, you said that list the reactions of what urea cycle and add notes on the significance of this pathway to man. So for the reactions of urea cycle, it's just quite simple. All right. So let's talk about it step by step. We have carbamoyl phosphate synthesis. Formation of this word carbamoyl phosphate. Formation of this carbamoyl phosphate. That's the synthesis, right? So what is the enzyme involved? The enzyme involved is what? Carbamoyl phosphate synthetase. Carbamoyl phosphate synthase. This is it. So let's use this image, right? So you can learn how to draw the image before we continue. Okay. So carbamoyl phosphate synthase. So what is the reaction involved here? This CO2 and NH2, they actually come together. So not everything is on one image, so we have to be switching. Okay. CO2 and NH2, they actually have to come together. All right. They combine with 2 ATP and they form the carbamoyl phosphate that we're talking about. What's the next step? Formation of citrulline. Of course, you can't understand this video at one glance. Okay, so do watch it many times. Formation of citrulline is basically what? The enzyme here is what? Ornithine carbamoyl transferase, or you could say ornithine transcarbamylase. Most enzymes, they have two names. Most enzymes are what? They catalyze the conversion of one stuff to another. They have two names. Either you're naming them from back to front or front to back. Okay. So what is the reaction here? Reaction here is this carbamoyl phosphate that was formed here will combine with ornithine. Ornithine is here, carbamoyl phosphate. They combine to form what? Citrulline. Okay. Then the next synthesis is what? Formation of what? Argininosuccinate. Argininosuccinate. What is the enzyme there? Argininosuccinate synthase. So actually, I took the reaction here. I was supposed to put it on this other side, okay? So the reaction here is this citrulline that was formed. Citrulline will combine with aspartate that is coming from outside, okay? The enzyme here is what? Argininosuccinate synthase, okay? Where's the enzyme? Argininosuccinate synthase, okay? And they will combine to form this argininosuccinate. So you have to draw that thing and be following me up. So next now, this argininosuccinate will be cleaved. Cleavage of argininosuccinate. Okay. So if you are cleaving argininosuccinate, that means you are breaking it down, you are lysing it. So okay. So the enzyme there is what? Argininosuccinate lyase. Alright. So it will basically what? Break down the argininosuccinate into arginine and fumarate. Okay. Arginine and fumarate. Okay. Then what is the next step? Formation of urea. Okay. So this arginine, let's see it. The enzyme there is arginase. Okay. So water will be added to arginine to form what? Urea and ornithine. Okay. So water will be added to what? Arginine to form urea and what? Ornithine. The ornithine can now go back and combine with carbamoyl phosphate so that the cycle continues. You get? So this image is a nice one for what? Revision. Alright? It's a nice one for revision. And even learning how to draw. Okay, so what is the significance of urea cycle to man? It helps in the detoxification of ammonia, right? So urea cycle converts what toxic ammonia, which is a byproduct of protein metabolism, to convert this ammonia into urea. Okay, and this ammonia can now be safely excreted in urine. Okay, the nitrogen balance. This process also what helps to maintain the nitrogen balance by efficiently removing excessive nitrogen from the body. Okay, the metabolic integration. The cycle is interconnected with other metabolic pathways such as what TCA cycles through shared intermediates like fumarate. Okay, so they have some shared metabolites that connect the cycle. So that means if the cycle is not present, some other cycles will not go on well. You get it? Then what is the clinical relevance of this urea cycle? Deficiencies in urea cycle enzymes can lead to what? Accumulation of this ammonia that is supposed to be broken down. That's what hyperammonemia, which is a condition with severe neurological implications, highlighting the importance of this pathway for human health. Okay, so the cycle overall is what essential for detoxifying ammonia and maintaining metabolic what homeostasis. Right, so that's it for what the reaction of what urea cycle and the significance of urea cycle pathway to man.